So hey guys.
Hello.
Anyways, so me and my group mates fun. We're working on adapting Crab's polymer chitin for adapting to body armor. That sounds like a mouthful, right, Stefan?
Oh, a whole bunch.
So, there we go. So, as I just said here, our objective for this project will be to test if the polymer chitin would be useful in making body armor. Whether to make body armor weigh less or to make body armor stronger. So, our hypothesis was that arthropods seemingly have virtually body armor. You know, they're capable of basically withstanding crushing pressures underneath, mountains and oceans, capable of taking massive impacts and damages,
Without getting hurt.
without getting hurt. So, strange. Oh, keep going the wrong way. So, what is chitin, Stefan?
It's a lightweight, it's like a body armor that they have. It's an exoskeleton it's made of nanotubes of different proteins that they produce in different areas. So it's got different strengths and thicknesses depending on where they need it the most, like the claws. It's high strength, more dense nanotubes than say like the inner leg or the joints or something like that.
As also here, this is a picture of a crab. If no one can actually realize that, I thought the image was pretty right. Anyways, so the chemical formula of chitin is C8H13O5N subgroup N. So, what we learned in biology the other day is that this has a carbon, 1 hydrogen, 13 hydrogen, 5 oxygen, and 1 nitrogen. And anyways, so what I'm going to talk about is body armor. Now, there are 2 different types of body armor that people currently wear. That is soft body armor, which is made out of a Kevlar vest, sort of interweaving with upper fabrics to sort of, when a bullet penetrates it, it just disperses over it over a wide range. And ceramic body armor, which is when someone shoots you, basically at a thick enough plate, it bounces off. Now, one of the interesting facts that I did not know about this beforehand, there is no such thing as bulletproof armor. Bulletproof should really be called bullet resistance, because even if something is rated for example, being shot with a
50 cal.
50 cal,
You explode.
you're going to die. Okay, so why would we want to add chitin to body armor? Well, body armor, if you didn't know this already, weighs a lot. For example, a U.S. Marine is going to be carrying around a typical load 97 to 135 pounds. Around 35 of those pounds is just body armor. Now, can you imagine being in the middle of Afghanistan or Iraq carrying around 35 pounds of armor on you? That's thick, heavy plates. That sucks a lot. Now, what we believe is that we can adapt chitin to either lighten the load for these soldiers. It would be a viable commercial product for both the U.S. military, police, defense contractors, et cetera, et cetera. Now, anything else you'd like to add into this, Stefan?
I mean, other than the fact that they're already carrying so much weight with all the pressure they have on their chest because they're pulling down and then they have the backpack and it's just squishing them, the lightweight is also, it'd be a lot thicker material, so it's like it would absorb more also, so you can have more weight dispersed on your body.
And our methodology for this will be testing different forms of chitin found in different crustaceans and seeing if different polymers could be formed into a workable form.
Because not all crustaceans have the same structure of nanotubes in their chitin. Like shrimps have a form of chitin, but it's a lot thinner, it's more flexible, it's meant to move with their body. As crabs and lobsters, it's rigid, does not move.
Which could, in theory, be our soft and hard body armor types, maybe. Anyways, so we use this data to start production. On saying, hey, if we can identify which types of polymers we can use, we can start wrapping them into to any existing, fibers and see if they're resistant to kinetic impacts. And here's our citations that we used, and that's the end. Questions?
Yeah.
Oh, there you go.
I like the idea, but what is the armor gonna be, like one piece that you're just gonna put on and?
No,
it's
we're
gonna
just
be
going to,
plates?
we're right now looking at adapting two different types of body armor. So soft body armor is
Which is more like a
basically,
cover, like you have the
You just put it
military
on,
vests on, and
yeah.
then, like
hard
a
body,
plate.
yeah, well, hard body armor, it's basically you're carrying on a normal vest, but then there's these pouches, right? Pull open the pouches and you slide in these big, thick, basically shields to protect your vital organs from getting shot.
Okay, so you're gonna have actual plates?
Yeah.
You're gonna put in place.
See if we can make them either lightweight or stronger. Any other questions? Oh, there, Dr. Coughlin.
So you're gonna try and spin the chitin into a fiber that would be like a replacement
Yeah.
for a Kevlar type
Yeah.
fiber? And then also create a harder structure. So like a crab shell is really it's a multi-layer composite.
Yeah. Which is like,
Hard-
It's like a fiberglass,
Which
it's
is
woven
like-
in different directions, so it's stronger, like a
Which is-
Lincoln log house.
which is like how body armor for hard body armor is used today, which is a thick ceramic outer plate, and then the inner plate is a thermal shock absorber, which stops most of the kinetic damage from hitting your body, which could,
Oh, okay, so I guess the question is, do you think you could really get a chitin fiber that would give you bullet resistance on the order of Spectra or Kevlar?
right now,
Possibly.
possible, maybe. It's just really going to depend upon how much weave we spin into it. And
Well, you have to understand, you have to try and develop an understanding of what makes Kevlar or Spectra Spectra.
It's the weaving pattern,
What is it? What?
it's the weave pattern that they have inside of it.
Well, no, the actual fiber itself is really strong, and that's part of the trick. What
Mhm.
makes the fiber strong is what's important. So Kevlar and Spectra are two different things, have two different mechanisms. The Kevlar mechanism is the one you guys could probably try and exploit with chitin.
In nature, as far as I know, I might be wrong, but a large majority of impact resistance comes from whatever shielding that they may have not being completely flat.
yeah, that's true. It's at a slight angular shape.
Right. It's got bumps, ridges, all that sort of stuff. Now, if you were to put it in the form of a plate, that would drastically decrease the effectiveness, don't you think?
Yeah, which you could angle the plate up.
Well, not body armor, the body armor that we have, is it,
It's not,
A sheet.
it's more like,
not a sheet,
it's like, it's sort of like this sort of shape, like a U. Not really U, like a slightly bent U.
Is there any way you could implement ridges in it to increase the strength, or would that interfere with the pouch?
That would probably interfere with the pouch. Hi there, Dr. Horton.
Okay, so it's very interesting, and I think there's a lot of concepts that you might need to explore to make sure that this could be visible, which I think would be. At the end of the semester, again, my generic question, but I think rather than a question, this would be suggestion. Considering that this is more of a hit and miss, you test which is better, the soft, the hard, I would go and start with modeling this.
Okay.
What about going to first modeling? Okay, let's start with, like Dr. Coughlin was saying, scaffolding, just laying out the layers and all that would be easier if you actually work on it on a model. Then it's easy for changing, and then you can probably simulate what, kinetic impact in a computer model?
you
Yeah.
can do that.
Yeah, you can do that, where you can now test, how hard is the pressure, how hard is the force, you can actually, like ridges and all of these suggestions. So, that being said, do you think it's possible for you guys to kind of start getting into the modeling?
Yeah.
Sorry.
I'm pretty sure means fun could
For sure.
good to modeling. Thank you for the suggestion.
Yes. Nice. I'll expect that at the end of the semester.
Okay. Any other questions?